Next, we'd like to graph quadratics in the general form, f of x equals ax squared plus bx plus c. Notice that this a is the same a that we found in f of x equals a times x minus h quantity squared plus k. The a is the same in both, so we can easily find the a value. Unfortunately, there is no identifiable h and k in this general form, and we need the h and k in order to find the vertex. So we must use a formula to find the h and k in order to find the vertex. So our formula for h is found by taking the opposite of b over 2a. H is equal to negative b over 2a. And to find k, we evaluate the function at h, the h you just found. Notice this is the value of the function at h. So that means that the vertex is negative b over 2a, comma, f of h. Or you can think of that as f of negative b over 2a. So let's try this on our first function. F of x equals x squared minus 2x minus 2. My a is still easily found by finding the coefficient in front of the x squared, which is 1. It's the h and the k that aren't as easily seen. So to find h, I'm going to take the opposite of b. Well, my b is negative 2, so the opposite of negative 2 is positive 2, over 2 times a, which is 1 in this case. So 2 over 2 is equal to 1. So my h is 1. To find my k, I'm going to evaluate the function at 1. F of 1 is 1 squared minus 2 times 1 minus 2, or negative 3. So my k is negative 3. Now that I have my h and my k, the rest of the steps follow as we've done previously. My vertex is still hk. Now I know my h is 1, and now that I know my h is negative 3, my vertex is 1 comma negative 3. And I can plot 1 comma negative 3 on my graph. I can also find 2 more points from my vertex by using my a. I know that my a is 1, so I can go left 1 and up 1 and right 1 and up 1 to find 2 more points. Notice I added an extra little step here. I snuck in the step 2.5. And the reason I stuck an extra little step here is because it's easier to have the equation written in standard form. And now that you know your h and k, you can rewrite your function from general form into standard form. F of x is equal to a, and my a was 1. You can write the 1, or we probably don't need to write the 1. X minus h squared, but my h is now 1, plus k, and my k is negative 3. So this is my standard form of the equation. This is the same equation as the general form, but now that you know your h and k, you can find your standard form easily. Why is this helpful? When I'm trying to find the x-intercept, I have to set f of x equal to 0. Well, I have two f of x's. I can either set 0 equals x squared minus 2x minus 2 and solve this, or I can set 0 equal to x minus 1 quantity squared minus 3. Which quadratic equation would you prefer to solve? Well, if it was me, I would prefer to solve in standard form because I can move the 3 over and use the square root formula. Whereas if I'm using it in general form, I'm going to have to use the quadratic formula. So this added step here, what's the standard form of the equation, is going to save you a little bit of time when you're trying to solve this equation to find the x-intercepts. You are welcome to use quadratic formula, but I'm not going to. I'm going to show you it in square root method. So we have plus or minus the square root of 3 equals x minus 1. Add 1 to both sides. I'm getting x is equal to positive 1 plus or minus the square root of 3. So that is my x-intercept. 1 plus or minus the square root of 3, comma 0. Unfortunately, 1 plus or minus the square root of 3 is not really easy to graph. So I'm going to need to actually take out my calculator and evaluate 1 plus the square root of 3. which turns out to be 2 point something. And 1 minus the square root of 3 means negative 0 point something. I don't have my calculator handy, but you can evaluate those to get a little bit more accurate if you want. But this is probably all you really need. 2 and a little bit, and negative 0 and a little bit. Let's plot those 2 points. 2 and a little bit will be right over here. As long as it's between 2 and 3, that's good enough for me. Negative 0 and a little bit will be between 0 and negative 1. And now I've got several points. To find my y-intercept, I can evaluate f of 0, where x is equal to 0, or you could just look right here on the graph. You already have the point negative 2 on your y-axis, so you can just pull that on over. If you really did evaluate f of 0, you're still going to get 0 squared minus 2 times 0 minus 2. And 0 minus 2 is still negative 2, so it's actually pretty easy as well. Next, to find the axis of symmetry, my axis of symmetry is always x equals h. In this case, x equals 1. And I can sketch that vertical line at 1 for my axis of symmetry. That's all the information I'm going to get for my sketch, so I'm going to sketch. Make sure you put arrows at the end, and that's a fairly good sketch of your quadratic equation. Next, my domain is always all reals. My range, because this arrows are pointing up, I have a low point, and my low point has a y value at negative 3, comma, how high can you go? Well, up forever. Because I have a low point, that tells me that I have a min. So I have a min value. Where is my min value? Well, my min value is negative 3. Where does that occur? At x equals 1. Again, that's always k value at x equals h. On my next problem, 3x squared plus 12x plus 10, my a is equal to 3. My h and my k are not identifiable from my function. So in order to find h, I'm going to use the formula negative b over 2a. My b is 12, so I have the opposite of 12 over 2 times 3, which gets me negative 2. My h is negative 2. Now that I found my h, to find my k, k is equal to the function's value at h. So I plug in my h of negative 2, which is 3 times negative 2 squared plus 12 times negative 2 plus 10. So 12 minus 24 is negative 12, and negative 12 plus 10 is negative 2. So my k is negative 2. Putting my h and my k together, I'm getting a vertex of negative 2, comma, negative 2. Using my a of 3, I can go right 1 and up 3, left 1 and up 3. I can already see that I'm crossing the x-axis, so I will have x-intercepts. To find those x-intercepts, I have to set the function equal to 0. Well, setting this function equal to 0 is not easy in general form, so I would like to find standard form, which is equal to a, which is 3, x minus h, my h is negative 2, so that's x plus 2 quantity squared, plus k, which is going to be minus 2. This standard form is going to help me when I'm setting f of x equal to 0 or finding the x-intercepts, finding what x equals when y is equal to 0. It's easier to solve from standard form, so I'm going to use the standard form instead of the general form. Add 2 to both sides. Divide both sides by 3. So I'm getting 2/3 equals x plus 2 quantity squared. Take the square root of both sides. Plus or minus the square root of 2/3 is equal to x plus 2. That leaves me with x is equal to negative 2. plus or minus the square root of 2/3. Now, evaluating -2 plus or minus square root of 2/3 is going to require a calculator. -2 plus the square root of 2/3 is going to turn out to be -1.19. -2 minus the square root of 2/3 is going to be -2.81. So I'm going to plot these two values, 1.19, -2.81, comma 0. -1.19 is between -1 and 2. -2.81 is between -2 and -3, which is exactly where we would hope they would be using our picture. My y-intercept is found by evaluating f of 0. If x is equal to 0, what is y, or f of 0? In general form, this is really easy because 0 squared is 0 times 3 is 0. 12 times 0 is 0. So 0 plus 0 plus 10 is 10. Using my axis of symmetry, and my axis of symmetry is x equals h. In this case, my h is -2, and we can sketch that on my picture. I can find another point at -4, 10. My y-intercept is 2 units away from my axis of symmetry, so I can find 2 units to the left of my axis of symmetry to find another point. So I have 7 good points here. I have a pretty good graph. My domain is always going to be all reals for quadratic functions. My range, notice I have a low point for my y values. My low point is at -2, infinity. My high point is forever high. Because I have a low point, that tells me I have a min value. A min value of -2 occurring at x equals -2. For my last problem, f of x equaled -x squared minus 4x plus 5. My a is equal to -1. I have an h value and a k value, although I can't see it here in general form. In order to find the h and the k value, I find h is equal to -b over 2a. In this case, my b is -4, so the opposite of -4 is +4. Over 2 times -1. I'm getting an h of -2. In order to find k, k is equal to f of h. And in this case, h is -2. To find f of -2, I evaluate the function at -2. So -2 squared is 4, and the opposite of 4 is -4, plus 8 plus 5. I am getting a k value at 9. So at -2, 9, I have a vertex. To get 2 more good points from my vertex, I can use my a. My a says if I go right 1 and down 1, and left 1 and down 1, I have 2 more good points. To find the x and the y-intercepts, I'm plugging 0 in x values and y values. Before I find the x-intercepts, I'd prefer to write my general form of my function into standard form of the function. I just rewrote my standard form up here just so it would be easier for you. F of x equals a, but my a is -1. X minus h, but my h is -2. So minus a -2 is really +2 squared plus k, which is 9. Notice the inside of the parentheses changes sign, although the outside does not change its sign. Why was this helpful? Well, when I find the x-intercept, I'm setting f of x equal to 0. It's easier to find f of x is equal to 0 when it's already written in standard form. First, move the 9 to the other side of the equation by subtracting 9 from both sides, or just using transposition, meaning if you cross the equal sign, you have to change the sign. Next, I'm going to divide both sides by -1. 9 is equal to x plus 2 squared. Next I take the square root of both sides, so I have plus or minus 3 is equal to x plus 2. And move the 2 over, I'm getting negative 2 plus or minus 3 equals x. Although no one writes negative 2 plus or minus 3 because I actually know what negative 2 plus 3 is. Negative 2 plus 3 is 1. Negative 2 minus 3 is negative 5. So these are my two x-intercepts. Negative 5, 0 and positive 1, 0. So we have negative 5, 0 and positive 1, 0, which looks like it's lining up just nicely, especially using my axis of symmetry here at x equals negative 2. To find my y-intercept, I can evaluate the function at 0. So f of 0 is negative 0 squared minus 4 times 0 plus 5. So you have 0 minus 0 plus 5 is just 5. Finding y-intercepts using general form is usually a lot easier than standard form. Next, I can plot my y-intercept at 0, 5. Notice that's 2 units away from your axis of symmetry, so you can go 2 units on the other side and get another nice point using your axis of symmetry. I've got 7 nice points, and I can sketch my graph. My domain is always all reals, negative infinity to positive infinity. My range, because I have a high point here, my low point is negative infinity, comma, my highest point that I have is at positive 9. Which tells me that I have a max value of 9 located at x equals negative 2. Again, not all of these things you'll be asked for every single time that you're doing a problem on your homework, but we have covered every single thing that you will need on your homework on every problem, so we've been much more thorough on the video than you'll have to be on your homework. So in summary, we talked about graphing quadratic functions, identifying the vertex, the x-intercepts, the y-intercepts, the axis of symmetry, stating the domain and range and maximum value. We've graphed from both standard form and from general form.